Hey CS1B students, can you believe that we are at the start of another semester? Wow, how time flies. So, what are we going to be doing over the next 16 weeks in a course entitled Introduction to Computer Programming? Well, in my opinion, every good class should tell an interesting story. There should be a beginning and a middle and an end. There should be a plot. There should be main characters. There should be character development and a narrative, and if the instructor can work it out, a cliffhanger from week to week. The story that I'm going to be telling you this semester, however, I'm not going to present it as chapters, but rather I'm going to give you a basic nub of a concept, basic idea. And then week by week by week, we're going to be building layers on this basic fundamental idea. So by the end of the semester, hopefully you'll have this pearl or this jewel of intellectual beauty that you can add to your neurological jewelry. So what is the basic fundamental concept upon which this entire course is going to be built? It's a machine, a tiny little machine that has changed the world. Here's an example of one, easily fits in the palm of my hand, and in fact the machine that I'm talking about is really only a small part of what's actually inside this silicon chip. I don't even have a good name for this machine. Some people call it a universal Turing machine after Alan Turing. Some people might call it a von Neumann machine. Some people would call it a computer, but I really don't like to call this a computer because a computer to me is a box with wires and a display and a keyboard, and this is something much more fundamental. I don't want to call it a microprocessor because a microprocessor is one particular instantiation. That is, one particular way of building this particular machine. So for lack of a better word, I'm going to call this a CPU. Now, the reason that I consider this little machine to be so amazing is that it allows me to actually capture my thoughts. Not all of my thoughts yet, but thoughts that I can put into the form of, quote, algorithms. I can capture them onto this little machine. And then, at other points in time, long after I'm dead and gone, this machine will recapitulate my thoughts. It's really an amazing device. In fact, in my opinion, as an educator, I believe that all students at some point in their college career should do a mental exercise. So I'll present that to you. You can think about this. We Homo sapiens occupy this pretty little planet circling a nondescript star on the outer arm of a perfectly ordinary galaxy. And we believe that we have made contributions, intellectual contributions, to the development of our species that have had an enormous impact on how we have progressed in this little homeland we call Earth. So here's the exercise that you should attempt at least once in your academic life. Write down a list of the top 10 achievements, inventions, advances that humans have done. So when you present this exercise to students initially, they start out with kind of the naive sorts of things, like students will put at the top of the list, fire. Well, humans didn't invent fire, but humans developed the means for controlling energy, and that probably belongs on a list like this because it allowed humans to migrate not just along a narrow band, an equatorial band around the planet, but to migrate to longitudinally along the planet into areas of the planet which would not be habitable for humans were it not for their ability to control their environment. So let's put fire on the list. What else do students tend to put on this list? Quote, the wheel. Well, this amazing little device of a wheel with axles allowed humans to transport themselves and goods, like food, over vast distances much faster than they could by themselves or with beasts of burden. That had an enormous impact on humans because humans were now able to aggregate into social organizations that we call cities. A critical mass of humans allowed the development of social structures which allowed populations to become much more powerful and effective than they could have if they remained in villages or in isolation. So let's put the wheel on the list. What else would I add to the list? Well, certainly I would add the concept, the invention of symbolic writing. Imagine how amazing is it that we can hear the voices of people who lived long ago. I can pick up books by Shakespeare, Euclid, Omar Khayyam, read those words, and my brain is firing neurons in synchrony with the thoughts they thought and wrote down hundreds, thousands of years ago. How amazing is that, that we can communicate with people across vast distances and vast epochs of time because of the invention of symbolic writing. Well, in my opinion, this little machine belongs on that top 10 list because this machine allows me to capture thoughts and replay those thoughts at different points in time, at different places, and also, by the way, much faster than I could myself originally. So it has created, if you will, an extension of the human brain. And it's unlike any other tool that humans have ever invented. You know, it's not like a stick that extends our reach, or a hammer that extends our force, or a telescope that extends our vision. This extends our mind, our thoughts. Over the years, I've seen so-called legacy computer programs. In the field of engineering, there's some basic engineering problems that people addressed in the 1950s and 60s in these old legacy Fortran computer programs. And in business processes, there are business process applications that were written originally in COBOL and RPG, and these programs ran on these huge IBM mainframes, and eventually they migrated to smaller IBM mainframes, and then they migrated to IBM's AS400, sort of their mini mainframe solution. And today, many of those programs are still solving engineering problems and performing business process analyses based on these original programs, even though they're running on desktop computers today. Every time one of those computer programs runs, programmers long dead and gone, a little bit of that programmer's mind is reincarnated. Just as when I read the words of Shakespeare or Euclid or Omar Khayyam, a little bit of their mind is relived in my brain as my brain duplicates their thoughts. So capturing thoughts in this little machine is very, very profound. So here you thought you were taking a course in computer programming, and actually it's much, much more profound than that. What we're going to be learning over the next 16 weeks is how do you capture thoughts, incorporate them into this little machine. Wow, how zen is that?